Sorry again for this short delay. Now we're going to have David. He's going to talk about very cool, interesting stuff about auto-remediation at Dropbox. So let's welcome David.
Hey, thanks for coming. I'm David from Dropbox. I've worked on Dropbox's in-house storage where we needed some very paranoid automation, stuff that would reformat hard drives, do really scary stuff, but at the same time safe. And that led into a separate project called Nauru, which in Japanese means to fix. And that's an auto-remediation system that I've pushed throughout the rest of the infrastructure teams of the company. So right now at Dropbox, we have a few dozen machine owning teams, and most of them use Nauru right now. My goal with this talk is to kind of share how to think about auto-remediation. Like if you're a small company that hasn't really approached automation or is kind of afraid of it, then I want to give you steps that you can use to start doing auto-remediation. So here's kind of the talk rundown. I'm going to kind of explain the problem, what I'm addressing, then give some kind of philosophical concepts on thinking about safe auto-remediation, and then I'm going to give some really specific details on how Nauru's workflow specifically is. I'm hoping to shoot for a pretty short talk, 15 minutes if I can get it right. I don't really want to burn time on things that don't matter much. So here's some background on what we do. So imagine you are a new intern on Dropbox's storage team. David Mod just tricked you into going on call because I do that with interns, suckers. So what do I have to do? Oh, I guess I have to clean some non-paging alerts, do some maintenance. What's that mean? What is this? What are all these things I have to do? Do I have to do 500 tasks? Okay, great. I guess I'll go do them. What are the actionables? Well, the actionables are stuff like rebooting a bunch of servers to pick up some kernel upgrades, but make sure not to do too many at once or the site's going to go down. Or make sure not to accidentally reboot one of our single points of failures, because we all have those, as sad as it is. Okay, what else is there? That's not too scary. Deallocate some hardware or replace it. Sometimes hard drive crashes, machine's still running, we need to get that out of production. Or maybe we need to move machines between racks or between clusters for other hardware maintenance. So we need to pull these servers out of production and then reprovision new servers to do the same task. Also easy enough, great. How about this one? After certain hard drives corrupt themselves, we need to reformat these disks. And we need to make sure that we don't accidentally reformat the last copy of a piece of user data. That's not too scary. Have fun, on-call intern. Good times. So it's really these problems. We need to automate them away, but we need to automate them away safely. Otherwise, what do we risk? A site outage, loss in availability, or data loss, a durability incident, whatever. No, that's not okay. And I don't even think, not even one instant of this kind is okay. We need to build our automation in a way where we're really, from the start, thinking, I'm going to cause 0 incidents. I'm not going to let anything through. It's not okay to be sloppy with this kind of stuff. And so, following up from that, what are the steps? This next section of the talk is kind of a life of tooling, or what is the roadmap with your tools? So the template that I kind of imagined, or here's what I imagined before building any auto-remediation or understanding it at all. First, everything is manual. You type a lot in the terminal. There's some maintenance that needs to happen. The maintenance could be because of something broken, or you just need, you need to do a kernel upgrade. We somehow realize this. Manually we realize this needs to happen, and then we manually make this maintenance happen. I think it's pretty risky to let any known type of work stay in this state of manual realization. So one step up. We add an alert. I think of an alert in this case as automating the process of finding work to do. Sometimes you think of it as automating of finding problems, but at Dropbox we often see our alerting system as a task management sort of system, an automated task management system. So here we have that. We've automated finding work, but not doing work. So one step up. Let's add a script that's going to fix the problem or do the work. So now we found the problem automatically, and we have a way to fix the problem automatically, a remediation. But that's not everything. We haven't truly automated everything because we have to automate the mapping of the alert to the script, and we have to automate the actual firing off of the script. And now, let's do that. Let's write a cron, and this cron is going to reformat hard drives. I'm so excited. This is going to be great. And I hope, I don't know, I hope this freaks you out, because it like freaks me out, or else if it didn't freak me out, I wouldn't have this job. But, so much can go wrong here, and that's what could freak you out. We've automated too much. We've jumped over way too much at once. And so, what can we do to, I guess, like, what is it underneath that I'm actually afraid of? And also, why is there like a convenient like gap in the slide? Well, what we introduced at Dropbox to kind of slowly figure out like what our fears were and how to defend against problems was this step called human authorization. And this is going to be the first step in finding a safe balance for protection but automation. So we've automated the mapping process. We have a tool that's going to find out exactly what we need to run, but it's going to ask for authorization. What is this remediation going to do? Why is it going to do this? And it's up to the human operator, the on-call, that intern, to understand what's going on, and they have to say yes or no. So this seems like simple. It is simple. What exactly is it giving us? It's giving us the opportunity to rely on a human to ask this question. Why should I not run this piece of automation? And there could be a lot of reasons. It comes down to human intuition. Like maybe there's an incident happening this very moment and everyone else is running around with their like heads on fire and I guess we shouldn't run this. Or maybe you notice the tooling tells you every host in the fleet is going to get rebooted by this, and at the same time. It's like that's unreasonable. Or maybe like the explanation, this like, oh, the kernel upgrade, like maybe like the task doesn't actually involve a reboot and that's confusing. Whatever, there's a lot of reasons that a human can think of to not run something. And this human authorization stage gives us the chance to ask that. So, the next step. This question, this work that the human's doing in deciding why not to run something, we can start to automate that. We can write tools that ask all of those questions for us. Like, is there a sev going on right now? We can write a protection that's going to check for this. Is the amount of hosts we're going to operate on above some threshold? Yes, the tool can also check that before proceeding. So we can replace this question with automation, and that takes time. So kind of looking back here with this life cycle, we can add this step where with human authorization, we blend this time where we're slowly adding protections to stop ourselves from running stuff. And eventually, once we've built enough protections that like the human pretty much says yes without checking anything because they're so confident, at that point, we can just jump to the last step where we run stuff fully automatically. It could be a cron, like whatever, like that's not important in this step of the talk. It's just, we have those protections. So, remember, like if you get anything out of this talk, with this tooling, why should I not run this? And if you ask that all the time, and then write tools that are going to automate asking that question and verifying the answers, that's going to protect your infrastructure from your tools and jump you through this safety gap of running scripts to fix stuff and fully auto-remediating stuff. So, great, that's like the philosophy. So here I'm going to give kind of like a more detailed run through because of Naru's like workflow, the pipeline for alerts and remediation. Because that previous stuff, it may have felt rather like theory-ish and conceptual. And I think this section will feel maybe like rather redundant, but like, I don't know, I don't see any problems with that. Redundancy in talks is pretty reasonable. And I want it to really feel like after this that building your own auto-remediation pipeline that fits your needs, like it's actually a potential reality. So here's the pipeline. We start with alerting. Alerting was automating the process of finding problems. So every alert goes into Naru's system we have a table of what we call diagnosed plugins. And diagnose plugins are these pieces of code that run non-dangerous logic. And the idea is that we want to decide on an action to take. You might ask, like, can't we just have a mapping of alert name to fix, like alert name to like path to a script? And the reason that we don't have this, or that we don't just do that, that we have this extra step, is that alerts can alert on either symptoms or root causes. If you want a remediation to fix a problem, you should be fixing something that you're sure of the root cause, not necessarily a symptom. Alerts on symptoms, like we can remediate them, but a diagnose plugin lets us zoom in even more. So here's an example of zooming in even more. We have some symptom-based alert for SSH. We're just checking if SSH is reachable or not. Someone writes a diagnose plugin that checks various things, like tries to SSH in itself just to verify if the alert is insane or not. Then after that, tries to go out of band, connect to the box, type in a lot of stuff and see how it responds. Maybe we find out that the machine is stuck in an init ramfs shell. The hard drive is like completely corrupted. Rebooting won't even do anything here. So why reboot it? We can decide on the decision to deallocate in that case. So that's a diagnose plugin, at least conceptually. So here's where that conceptual like safety balance stuff comes in. First, so the diagnose plugin is going to spit out this prescription. It's going to say, hey, I'm going to do X task, or it looks like this. And it's up to the human to say whether it's okay. What the remediation is going to do, why, and is it okay? Like, what should I trust about this? And if the human says okay, then we flow into a system of what we call pre-remediate hooks. So every pre-remediate hook runs on every single remediation. These are verifications that are going to replace the human asking questions, like the paranoid questions. For Dropbox, the highest leverage protections that we found going here are rate limits and availability checks. And then we've also added in some small ones like only run remediations during business hours, or only run remediations on one data center at a time to provide isolation. Here's an example of a pre-remediate hook for a Zookeeper server. It's pretty simple. It's if the ensemble members are alive, then it's okay to go forth with this remediation. Otherwise, we're going to punt it to later. And if we're having an incident where, say, Zookeeper is down because of hardware problems, or some of the servers are down, or even if it's Nauru's own fault for causing Zookeeper to start to go down, then Nauru will back off with an availability check like this. Here's an example of a rate limit. A rate limit stops instantaneous incidents, so like bowling over all of production at the same time. And the reason at Dropbox that we found rate limits to work really well with availability checks is that if Nauru starts to do work on production, like reboot a server, it can only do so few at a time, like one per every few minutes in that, like, for that service. If there's a problem with the remediation, the availability check will cause us to not run any more remediations. So we'll back off and things won't get particularly horrible. Rate limits also give us opportunity for humans to respond in case of an incident. So if we, for instance, don't have a reasonable availability check, with rate limits, usually our teams will get paged if something's going on before Nauru can like really cause a lot more problems. I guess the theme here is that we don't actually fully trust Nauru, and that's part of the point. So then after those pre-remediate hooks, we're going to run some remediate plugins, which these are what was suggested by the diagnose plugins. This is going to be logic to actually fix problems, like actually run a reboot or deallocation of a server. And if this remediate plugin fails, the alert is going to re-enter this entire pipeline. We bump a counter called like number of remediates attempted, and an on-call can use that to have visibility into failing remediations to operate on manually. Or even some diagnose plugins look at the history of remediation to decide on different courses of action. Like a reboot didn't work, then on try 2 we'll switch to a deallocation. After this remediate plugin, then we're going to try to like kill off this human authorization. At a certain point, having humans authorize every remediation is poor usability and like overwhelming to the operator. So if a human's only hitting yes because they're fully confident, it's time to get rid of human auth and let this thing run completely automatically. Note that that's on the basis of specific remediations. So we can kill off human authorization on reboots, but still enable it for reformatting of hard drives. It's important that we only remove our protections like this on one remediation at a time. And yeah, that's the entire flow here. You need this entire pipeline to send your alerts through. You can't just take everything and add in all the protections and get rid of human auth and then add all your alerts. For each alert, you need to walk it through the pipeline of having human auth, adding new protections, and then getting rid of human auth. And yeah, I hope this helps you design something that fits your own company's needs. Start small, but do something similar, I hope. Thanks. Yeah, we can have like 1 or 2 questions.
So what can you do to prevent damage by remediations which haven't run in months and things have changed since they ran and they now consult the wrong database to find out it's safe and end up destroying something?
Mm-hmm. So when I think of stopping tooling from doing lots of damage, there's like either slowing down the amount of work that it can do at once, or there's B, adding safety nets so that even if something horrible happens, it won't actually be all that horrible. So in the case of like the reboots taking down all production, being worried about now damaging stuff is handled by rate limits to slow everything down. In a case of say like connecting to a database and accidentally like wiping everything, that is, I guess your concern is that that's not granular. We can't split that up. We can't slow down the damage. So we need a safety net in that case so that even if we lose the database, the site will be okay. So that's the response, or in the Nauru world at Dropbox, that's the responsibility of the databases team to make sure that they have slaves and that even if we operate on like, say, a master and like reboot that in the wrong case or deallocate that, a slave will be promoted to replace it. So I guess Nauru has its own ways to introduce protections and stop itself from like damaging all of your infrastructure, but you still need to design your infrastructure to be resilient. Yeah. Any other questions?
Sure, I have a small question. So thanks for talking about this. I'm curious what's built into the system to deal with things like race conditions or 2 people running scripts at the same time or anything along those lines?
Mm-hmm. So like race conditions, do you mean between, okay, I guess there are 2 tiers. There's like race conditions between code or like different remediations running at the same time, which is rather similar to like, say 2 human operators like trying to do stuff at the same time.
Right, that was the second question, yeah. The race conditions were also between I probed the state to make sure everything was fine and maybe I waited for you to answer, or I probed the state and the state changed before the remediation was due to happen and something changed about what was probed that made that remediation actually be bad.
Yeah, so repeating the question in like kind of centric to this way, maybe like, so diagnosed plugins produce like prescription and like an explanation of like what can happen or what will happen. And then remediations happen like at some point in the future, right? So there's definitely some sort of race condition. With Nauru, we accept a few minutes of a race just kind of inherently. And what happens is diagnosed plugins actually rerun on our alerts every 5 minutes and regenerate a prescription. The prescription, like depending on the action, has a key of sorts that if this key changes, like if the diagnosed plugin suggests something different, then we reset the state, we need human authorization happen again, all that sort of stuff. So that stops us from, or I guess that like keeps our bound of probe to action within like a certain range. Then to stop race conditions like within that range, we rely on the rate limits. So if we have, like if we're gonna operate on a Zookeeper cluster, an ensemble that has 5 hosts, and we know that the bound for diagnosed plugins, like knowing, like being able to make decisions is a few minutes, then we'll configure our rate limits to only allow operations maybe every few dozen minutes. And then the rate limits doesn't have a race.
Cool. Thank you very much.
We don't have time for more, but I'll hang out outside. Thanks.
Because we need now to merge the rooms again.